All right. Today, exciting stuff. We're going to take a look at section 2.5. You guys get to use a little technology to make your lives easier. We're going to go slow through some things just to make sure we have the right keystrokes. For all of you at home that have the 84 plus, awesome. Our keystrokes are going to be the exact same. If you bought a Casio or do not have a graphing calculator, you can use Desmos on your iPad, or if you have the Casio, you're going to need to look the keystrokes up online or touch base with me in class, and I'll try to get you situated with those keystrokes. But for the sake of the day, we're going to use the 84 plus, and you can hopefully see it on the screen now. It's my giant calculator as far as things go. You can see I actually set up some lists prior to here, but let's get going. So 2.5, we just got through talking about, slopes and rate of change and setting up linear equations, okay? The nice thing about lines is a lot of times data we can fit to lines, and that's what today is all about. So we're going to be looking at scatter plots and lines of regression. So I know it's kind of squeezed off to the side here. Not a super big deal because you can see all the pictures still, okay? But we're going to be looking at bivariate data. Bivariate data is just data that has two components to it, okay? And if you look at this continuum, we have, it starts kind of over here on the left where we have information that is perfectly correlated in a straight line, okay? So if we had an linear equation, every x and y we plugged in would fit exactly to the same line, okay? Then we're going to continue on this continuum to the right. This still looks like our points are trending upward, but they're not a perfect line. So if you notice, they have a lower correlation value, okay? Even still, if we go one more over, they look like they have a positive correlation still, but it's even lower. They get more spread out. If it looks to, as I like to say, looks like somebody sneezed on the page, that has no correlation. So as the points move to the right, they don't go up, they don't go down. As we continue on further, our points trending downwards, a little more scattered, notice have a negative correlation value. That is because our points trend downwards, so they have a negative slope. Obviously, the more consolidated or more condensed they get, they're going to have that higher correlation value. And if they're perfectly correlated to a negative sloped line, they're going to have a correlation coefficient of -1. So again, just keep in mind, as we're looking at information, we're going to point out this R value later, but it's always going to be between 1 and -1. If it's -1 or 1, it has perfect correlation. And then the closer to 0 it gets, the less correlated the data is. The general idea is we want to take our information and fit some sort of prediction equation to things. Well, the nice thing about this is we just got through doing lines, so we're going to use lines to fit our data to some sort of model as far as things go. Okay, so first things first, we have a situation here looking at privately owned single-family homes for 6 consecutive years. All right, so I'm just going to label my axis and create a scatter plot. You don't need to do this if you don't want to, not a super big deal. And this is going to be in terms of hundreds of thousands of dollars as far as things go. So I'm just going to create a basic scatter plot. So we're at 154.5. 1 is slightly higher at 166.4. 2 is at 181. 3 is at 207, so just over. 4 is at 228, so we'll say right about there. And then 5 is going to be at 273, which we'll say is up here. Okay, if you notice, the values don't fit that line perfectly, but what type of correlation would you say they have? Well, if you look at how these points fit with what's up above, I would try to say that it has a high positive correlation to it, okay? All right. As we continue with this, we want to sketch a line of fit, all right, and write the prediction equation. Whenever it says prediction equation, you guys, that means I want you to do it by hand. I don't want you to use technology at this point to figure it out. I want you to create your own model by hand, okay? Well, in order to fit a line to a set of data, we need to kind of pick some points. So we need to pick 2 points from our data set to create the line. And oh, did I hear somebody say they want to use 1 and 3? Thanks for volunteering that information. If we're going to use 1 and 3 as our data points, think about what we did in 2-4 to create that line. So we need to figure out our slope. So I'm going to do 207 minus 166.4 over 3 minus 1. And I'm going to get my slope is about 20.3. All right. Then at that point, once we have our slope, we want to write our prediction equation. So the equation of this line is y. I'm going to use this point. Minus 207 equals 20.3 and x minus 3. So that is what's called, again, my prediction equation. So that fits my red line precisely. All right, the last question is, we're going to use our model to predict in year 8 what the price of homes are going to be. So what are we going to do? Well, we're going to take our model, y minus 20.7 equals 20.3, and I'm going to plug in 8 years from now and figure things out, okay? So we wind up with, I'm just going to move this thing over. We're going to add 20.7 to both sides to get y by itself, and we're going to get 308.5. So in year 8, it looks like the price of homes is going to be $308,500. And the final question is, does it seem like that's pretty accurate? Yes, it does, given our model. Will the model always be accurate? Probably not, because if you know home values fluctuate with the market, they might not always coincide. So again, that's how you create your prediction equation. You want to draw a scatter plot, describe your correlation. Is it high or low? And is it positive or negative? You then need to pick 2 points from your data set to come up with the slope. You might have a different slope or prediction equation than your neighbor. That's okay with prediction equations. It's your prediction. It's your unique prediction. They don't have to be the same, okay? Then typically after we go through that, we're going to use our model to make a prediction about the future. The second part of the day, we should end up with the exact same answer regardless of, I guess we're not choosing points. We're going to do what's called linear regression, okay? And linear regression is using technology to come up with the line that that best fits our data, okay? So the red line we drew on the last slide was a line that fit. It may not have been perfect, but it fit the data. Linear regression lines use technology to figure out what line best fits our information, okay? And right now we're going to walk you through the steps on your calculator to create that information. So again, we're going to go through this slow. It's going to take some keystrokes to get used to things, but then we'll kind of turn you loose. After you do this 2 or 3 times, you guys, it's going to stick in your brain about how to do this. I've included screenshots, and I'll try to, keep track of things as we go through. But the first thing is we need to enter our data, okay? And typically what's going to happen is when you set up your data, you don't want to type in 1980, 1983, 1990. What it's going to say is it's going to say, like, let X be year from 1980, okay? So then we know this is going to be 1, This is going to be 3. This is going to be 10, 15, 20, and 26. It's very important you get those X values set up correctly. Otherwise, you're going to have a slightly different y-intercept in the end. Your slope, however, will be the same, okay? So looking at this, we need to set up our table. So what you're going to do is you're going to go to your stat menu. Stat is right to the left of the cursors, and you're going to edit your list. So you'll want to hit enter. I've already went through and set up our information. So we have 0, 3, 10, 15, 20, and 26 as our X values. Your Y values will go in list 2. 73.7, 74.6, 75.4, 75.8, 76.8, and 77.7. All right. So that is step 1. We've entered our lists. Okay. I'm going to show you a little caution. So let's say we have a list set up and I don't want to use it anymore. Do not use delete on your calculator. Okay. What you want to do is arrow up to the top list you want to complete or clear out, hit clear, and then enter, and it will automatically clear all of those entries. You obviously can overwrite an entry as well. Otherwise, let's say you had a typo on this one. If you hit delete, it will remove that entry. But you notice it just shifted everything down. So I'm going to have to retype in my information. So we have 74.6, 75.4, 75.8, 76.8, and 77.7. My apologies for that delay there. We now need to go on to the next step. So we're going to create a scatter plot, and we're going to just try and look at our information, okay? So what we're going to do is we're going to go to y equals, okay? My apologies for having that equation there. Just clear it out if anything's in there. You actually want to do second y equals because that's where stat plot is, okay? At this point, we want to just use plot 1. We're going to turn it on, so I'm going to hit enter and make sure on is highlighted, okay? The first type is going to be your scatter plot, and then if we use columns 1 and 2 in my stat list, L1 and L2 are what it's defaulted to, okay? If you need to change it to something else, you're welcome to, but if we just keep using L1 and L2, your calculator always defaults to those. Let your creativity flow at this point. You get to pick what your mark looks like and what color it is. Exciting stuff, okay? And then a lot of you are going to hit graph at this point, and you're going to be like, what the heck? I don't see anything. Most of your graphs are going to look like this. You're going to be like, where did it go? I plugged in my points, I turned on my plot, but what the heck? Why don't I see anything? Well, we need to change our window around, okay? You need to make sure your window always fits your data. And if you think about it, our X values went from 0 to 26. So it makes sense that I might not see anything. But if I make them 0 to 30, I should have all of the X values in my table. On that same idea, my Y values went from 73.7 to 77.7. So I might choose between 70 and 80 because I know all the Y values in my table fit that information, okay? It's extremely important you change your window, otherwise you're not going to see your points. At this point, we can hit graph, and then you see your data, okay? So we're now on step 3. We rearranged our window, we set our data, and I would say these points have a high positive correlation. All right, if you were asked to describe this data, that's what the picture is for. Now at this point, we're going to use what's called linear regression to fit a line to this data. So I'm going to quit. I just do second mode. I'm going to quit out. I'm going to go to my calculation screen. To run linear regression, we're going to go to stat, all right? And we're going to arrow over to calculate. What we want to do is we want to calculate linear regression. So I'm going to arrow down or hit the number 4, and it's going to pull up my menu for linear regression. At this stage, you just need to make sure everything is correct. I did plug my x's into L1, my y's into L2. If you want to store your regression equation on your data, what you can do at this point is hit bars, which is just kitty corner to that down key, arrow over to y bars, pick function, and then you can select whatever y value you want. Okay, if I just select y1, what you're telling your calculator is whatever line it comes up with, I want you to automatically just copy that over to y1 so I can graph it quickly. Again, you don't have to do that step, but it's helpful for a visual. Then we just arrow down to calculate, and voila, we have our slope, which is 0.144, and our y-intercept of 73.889. Again, like I said before, if we go to y equals, it automatically shifted that line over and saved our regression equation to y1. So if I wanted to see my regression line on my graph, it's there for me, okay? So that's how we do linear regression and come up with our answer. Super awesome as far as things go. But I wanted to go back to our calculation screen. The one thing I did want to point out is if you notice when we ran our regression, it didn't tell us an R value, okay? So if we go down to our catalog, which is second 0, arrow down to D's and find your diagnostic, okay? So we're going to arrow down a little bit. We're going to find diagnostic on, and you're going to want to hit enter twice. The nice thing about this is once we run our regression now, so I'm going back through those steps, I'm going to run my regression. If you notice, the screen changed. It not only gave us our A and B value, but it also gave us our R value, okay? If you recall before, our R value is that correlation coefficient, and 0.99 obviously is very close to 1. So like we said before, these do have a high positive correlation. The nice thing about the step we just did is every time we use my calculator from here on out, as long as it's not reset, your R value will always be on, okay? So kind of continuing back to our notes, we went through the steps. We did our linear regression. Again, you can pause, rewind, fast forward, do whatever you need to do to get through those steps, but do it a couple times in your assignment and you should be good to go. But like I said, we use linear regression to come up with our equation, all right? So in this case, it was 0.144x plus 73.889. So if I wanted to predict life expectancy in 2025, well, if we look at this, again, it's year from 1980. So I would want to plug in 45 for my year, and then I just use this model to predict life expectancy, which is about 93.7 years. Okay. Again, using that technology to help is going to give us that linear regression line of best fit rather than doing it by hand and just having a line that's close. Okay. So linear regression, we're using technology to come up with the line that best fits our data. Again, do the assignment listed in the weekly learning guide and on Schoology. If you have any questions, utilize the discussion board or chime in live during class or on Wednesdays from 9 to noon. Again, the link at Google Meet. All you have to do is join Math Wagner live, and you'll join our classroom session in progress. So if you have any questions, find me there or utilize the discussion board. But that is 2.5. I know it was a lot of information thrown at you, but it's all good stuff. And once you do it a couple times, you'll have those keystrokes down. So best of luck on 2.5. Shorter assignment today, but like I said, there's a few more keystrokes, but should be okay. Let me know if you have questions. Enjoy.